Assalamualaikum and hi. So now we are going to look at 7.3 satellite motion in a circular orbit. So our first learning objective here, 7.3a, is to use the escape velocity where the symbol V subscript E is used, and also to derive and use the equation for satellite motion. The equation here is the velocity and also the period. So first we are going to look at what is escape velocity. Escape velocity V subscript E from the Earth is defined as the minimum velocity required by a body on the Earth's surface to escape completely from the gravitational pull of the Earth. So it is basically the velocity required for a body to escape from the Earth's surface. So let's say we have the Earth, and this is the center of the Earth, and our object is located on the surface of the Earth. So what is going to happen here is, for it to escape, it requires a certain velocity. Okay, that velocity is what we call as escape velocity, ataupun velocity yang paling minimum untuk dia escape daripada that gravitational pull that we're going to experience from the center of the Earth itu. Okay, it is not necessary it must be from the Earth sahaja. Okay, escape velocity boleh jadi, let's say you have another orbit here. Dekat orbit sini kita ada planet lain, and the object is located in this particular planet. Sama juga, you can still experience escape velocity sebab this object akan experience the gravitational pull daripada Earth juga, sebab they are still close where they can still experience that gravitational pull. So dia tak semestinya from the Earth sahaja. Dia boleh jadi escape velocity from mana-mana, from any planet. Escape velocity from any planet is the minimum velocity required by a body on the surface of the planet to escape completely from the gravitational pull of the Earth. Object itu, let's say the red color, is the object sitting on a planet, and dia nak cuba escape daripada permukaan planet itu. Okay, so dia nak cuba escape pergi ke infinity, where it has to overcome all this gravitational pull. Okay, so velocity yang diperlukan dekat sini adalah escape velocity, ataupun kita panggil minimum velocity, untuk dia try to escape ataupun untuk cuba larikan diri daripada the gravitational pull yang kita akan experience due to this Earth sini. Okay, so if you were to use object on the planet, so R dia dekat sini kena R daripada center of the Earth masih. For a body to escape from the gravitational pull of the Earth, it must have sufficient kinetic energy to travel to the infinity. So untuk dia escape, dia memerlukan kinetic energy yang secukupnya supaya dia boleh sampai ke infinity. The kinetic energy required by the body is equals to the gain in the gravitational potential energy when it moves from the Earth's surface to infinity. So bila dia berada pada permukaan bumi ini, dia akan ada satu energy, okay, gravitational potential energy, which kita dah belajar, negative G mm over R. Whereas since it is located exactly on the surface of Earth here, so the R here, the distance dekat sini akan sama dengan radius of the Earth. So saya letak R dekat sini, and then when it travels goes to the infinity, bila dia sampai dekat infinity sini, dia akan ada another gravitational potential energy, iaitu negative G mm over R itu. The R here is now the distance from the center to wherever the location is, which kita panggil dia infinity. Okay, which kita panggil dia infinity. So the gain in the potential energy from here to here is what the kinetic energy you require. Is the kinetic energy yang kita perlukan basically. Okay, the gain in the potential energy from the Earth surface to the infinity adalah the kinetic energy that you require for it to escape dekat sini. Okay, so K is equals to gain in the potential energy. So half mv square is equals to U infinity minus UR. U infinity adalah potential energy at the infinity, and then U at R here, UR here is U on the surface, sebab dia betul-betul berada pada permukaan. So jarak kita adalah radius of the Earth surface. Sorry, radius of the Earth. Okay, so now if we were to insert the equation here, K adalah half M, tempat V kita substitute escape velocity samakan dengan U infinity minus UR here. U infinity, since it is at infinity, jarak ini adalah infinity. Anything divided by infinity, you get a 0. So you can get U infinity as 0 here. And then minus, masukkan equation of the potential energy GMM over R adalah radius of Earth because it is exactly on the surface of Earth. So you will end up with your potential energy. Gain in the potential energy adalah sebanyak GMM over radius of the Earth. Gain in gravitational potential energy. Gain in gravitational potential energy itu. And then you rearrange this equation. Now what happened here is kita ada half mv square dekat sini. Okay, kita nak cari escape velocity sahaja, maka awak bawa lah 1/2 m ni, awak bawa ke sini, iaitu you divide them and then you bring the square here, get your square root. So you will end up with escape velocity is actually equals to surd gm over r. Escape velocity here is the surd to gm over r. Okay, so gm dekat sini adalah constant. G adalah 6.67 times 10 to the power negative 11. Mass dekat sini adalah mass of Earth, which is 5.98 times 10 to the power 24 kg. And R dekat sini adalah radius of Earth, 6,400 km. So semua nilai ni adalah constant dekat sini. Okay, so when you multiply the gravitational constant with the mass gm here, bila kita darab dua benda ni, G dengan M ni, you can get a value which is equals to the gravitational acceleration 9.81 darab dengan radius square ini. So they are the same, they give the same value. Therefore, you can simply substitute your V escape is equals to 2gm over R, since gm adalah gr square. Saya substitute yang ini. So you will end up with surd 2gr. Okay, so this is your escape velocity. However, you do not need to know how to derive sebab dia kata use sahaja escape velocity. So you should know how to use this equation, iaitu surd 2gm over r ataupun surd 2gr dekat sini. Depends on the question. Alright, next we're going to look at velocity of a satellite in a circular orbit. Velocity of a satellite in a circular orbit. So, apa yang ada dekat sini adalah you have a planet here. It could be any planet, boleh jadi Earth ataupun apa saja. Kita ada planet dekat sini, and then this satellite is going to orbit around the planet now. Consider a satellite of mass m. So, m kecil dekat sini adalah mass of the satellite here. Okay, travelling around the planet of a mass of capital M. So, this is our planet with mass capital M in a circular orbit of radius r. So, orbit ini, this orbit where your satellite is going to travel has a radius of the orbit adalah sebanyak r kecil with a constant speed of v. So it is moving with a constant speed of v as shown in the figure. Okay, so since the force is going to move in the orbit here and the orbit is circular, as you can see, it is making circular motion. Okay, it is making circular motion. Alright, dia akan membentuk circular motion because the satellite is moving in a circular orbit here. So it is going to have Fc is equals to mv square over r. Ini adalah chapter 6 kita belajar centripetal force. Any object that moves in a circle will experience centripetal force, iaitu mv square over r. And we also have encountered in chapter 6 that forces yang akan contribute untuk centripetal force could be any forces. Okay, dia boleh jadi apa-apa sahaja force dekat sini. As you can see, you have a planet and a satellite here. These two objects here will experience gravitational attraction force. Mereka akan tertarik towards each other. Gravitational force. So basically, the force that contributes to the centripetal force is actually the gravitational force. Okay, force yang menyebabkan objek kita untuk bergerak dalam bulatan ini adalah sebenarnya disebabkan oleh gravitational force that is being experienced by these two object, iaitu planet M dan juga satellite kita. They will experience Fg, and Fg adalah the first equation that we have encountered in this chapter, which is Gmm over r square. So since the Fg is the force that contribute to the centripetal force, so basically Fg is equals to Fc. So kita boleh samakan Fg dan juga Fc here. Okay, so Fg adalah Gmm over r square dan juga Fc adalah mv square over r here. So what you can do here, you are going to equate the, ini adalah Fg sama dengan Fc. So kita masukkan Gmm over r square sama dengan mv square over r here. Okay, dekat sini kita ada beberapa term. Ini adalah G, gravitational constant. M besar dekat sini adalah mass of the planet. M kecil adalah mass of the satellite here. Bahagi dengan jarak di antara Earth dengan satellite itu from the center here. So this is our R here. Okay, and then centripetal force is experienced by the satellite. So objek kita adalah satellite dan satellite ini yang membentuk circular motion ini. Maka we are talking about centripetal force by the satellite sahaja. Therefore the mass here is the mass of the satellite. This is the mass of the satellite. Darat dengan velocity dia, iaitu velocity at which the satellite is going to experience linear velocity, bahagi dengan r here, jarak of the, which is basically the radius of the orbit lah, which is basically the radius of the orbit. And then what you can do here, you can cancel the m, and then you can also cancel the r here sebab kiri kanan ada. Okay, so you will end up with G m over r sama dengan v square. Kita nak cari the velocity at which the satellite going to orbit. Kita nak cari velocity of the satellite in the circular orbit. So kita nak tahu apa kelajuan satellite itu guna untuk dia membuat bulatan itu, untuk dia mengelilingi planet tersebut. So you rearrange v, you bawa square ke sini, become square root gm over r. Okay, so basically this is the equation for your satellite's velocity. V is the velocity of satellite, G is the constant, gravitational constant, M is the mass of the planet, boleh jadi apa saja planet, boleh jadi Earth juga, depends on the question. And R here is the radius of the circular orbit, ataupun kita cakap daripada center of the planet sampailah ke kedudukan satellite itu. Okay, so you have to take note here where R dekat sini macam saya cakap daripada center sampailah kedudukan satellite. So you have to be very careful. If your planet is radius of if your planet is Earth ataupun apa saja planet sekalipun, dia akan ada radius dia sendiri. Radius dia sendiri adalah kita guna capital R here, radius of the planet. And then kedudukan satellite selalunya dia akan guna perkataan satellite is located, contoh 3 km above the Earth surface ataupun above the planet, ataupun dia cakap 5,000 km above the planet. Maksudnya kedudukan satellite kita adalah daripada permukaan bumi, iaitu from here to here. Ini yang dia cakap. So this is the H here. So to find the R here, you have to plus the radius of the planet with the altitude ataupun height where the satellite is from the surface. So kena berhati-hati, read the question carefully. Okay, next kita nak cari period of the satellites orbit the Earth. So we know the satellite is going to orbit around the Earth. Kita tahu satellite ini akan mengelilingi planet kita. So as the satellite is going to orbit around the Earth, okay, dia akan complete one cycle dekat sini. Objektif seterus kita adalah to find the period, iaitu time taken to complete one orbit. Time taken to complete one orbit. Time taken to complete satu pusingan, one cycle here. So from chapter 6, circular motion, kita tahu linear velocity is equals to r omega, where omega is equals to 2 pi over t. So what we can do here is we're going to substitute the omega in this equation. R omega adalah 2 pi over t. And then you will get V is equals to 2 pi r over the period. So now you can actually rearrange this to get your period sebenarnya. Boleh dapatkan period. Period adalah 2 pi r over V. Okay, and then if you can see previously apa kita belajar adalah the velocity at which the satellite going to orbit. So masa yang satellite ini akan ambil to complete one cycle depends on kelajuan yang dia guna. Okay, depends on the kelajuan yang dia guna. The time taken to complete one cycle depends on the speed here. Okay, it depends on the speed here. And the equation for velocity kita dah deduce, iaitu gm over r square root daripada sini tadi, this equation. Okay, now you can substitute that into the equation here. Awak akan dapat period sama dengan 2 pi r sert gm over r dekat sini. And then you do your max, you rearrange, awak akan dapat period kamu sebanyak 2 pi sert r cube over gm. Okay, you must know all this process of derivation. Begitu juga untuk velocity pun kena tahu process of derivation ini, sebab the learning objective here is to derive and use. Bukan use sahaja, kena derive. Okay, so saya bagi tips dekat sini untuk cari velocity of a satellite. Kita akan start dengan centripetal force is equals to mv square over r. As the satellite orbit around the earth ataupun planet in circle, so kita akan experience centripetal force. Kena ada force yang contribute to that centripetal force. Okay, apa force yang contribute to centripetal force adalah sebenarnya kenapa satellite itu boleh bergerak dalam bulatan, kenapa dia tak boleh gerak dengan terus, adalah sebab dia memiliki daya tarikan dengan planet dekat tengah sini. So dia akan experience that attractive force dengan the planet at the center here. So attractive force itu adalah sebenarnya gravitational force. So Fg pula sama dengan Gmm over r square. So to find the speed of the satellite, you equate Fg dengan Fc. Equate the centripetal force with the gravitational force, and then you get your V. Dapatkan V, kamu derive lah. For the period pula, untuk dapatkan period, you start from the linear velocity daripada chapter 6, V is equals to r omega, and omega adalah 2 pi over t. Okay, and then you substitute V is equals to 2 pi r over the period. So sekarang dah ada term period ini, kita nak cari period ini. Okay, whereas V tadi kita dah belajar adalah V sama dengan sert gm over r. Then you substitute that into here. You do your max, awak akan dapat period kamu sama dengan 2 pi square root r cube over gm. So this is the period of the satellite. So the t here is the period of the satellite. Okay, 2 pi adalah constant, r dekat sini adalah radius of the circular orbit from the center lah kan, basically sebab kita akan ada planet dekat tengah, and then kita akan ada satellite dekat sini. So jarak kita dekat sini adalah jarak of that circular motion. Circular motion kena daripada center of the circle. Ini orbit kita, so inilah jarak dia. Okay, this is the r from the center of the planet, and g is the gravitational constant, and mass dekat sini adalah mass of the planet. Siapa yang dekat tengah tu? Siapa yang kita mengelilingi? Mass of planet. Alright.